Okay, power functions. So, power functions is any function in the form of a times x to the nth power, where a is a number that cannot equal 0, and p is also a power that cannot equal 0. I don't know why I put p. That should be n. Whoops. N is a power that also cannot equal 0. Or n is a power that is a number that cannot equal 0. Holy cow. Yeah, you got me. Okay. So, a constant, that's f of x equals c, where c is a number, and that is just a line. Okay, linear, that's f of x equals x, and it's a diagonal line that just goes straight through the center. Quadratic, that's f of x equals x squared, so that's that U-shaped graph that we've worked with. Cubic is f of x equals x cubed, and that starts low and ends high. Quartic, that's f of x equals x to the fourth, and that is essentially the same as the quadratic graph. So the difference between these, let's do quintic real quick, and then I'll show you the difference between these. Quintic, x to the fifth, that's kind of the same as the cubic graph. So if you notice, all the even powers, so this one and this one, they look the same, right? But this 4 tells you how many times it can touch the x-axis. So this could really go like this. 1, 2. See, it touches 1, 2, 3, 4. Okay. Now, odd powers will give you a graph that looks like this. Now, if it's 3, that means it could touch 3 times. So you could go 1, 2, 3. 1, 2, 3. 5, you could go 1, 2, 3, 4, 5. Okay, but these are just what I drew very first. That's really all you need. Okay, but that's what the difference is between the 3 and the 5 and the 2 and the 4, and so on. Okay? All right, let's look at this. So if a function has an even power, then it's symmetric about the y-axis. If it has an odd power, then it's symmetric about the origin. We've done that before, so hopefully you can remember that. Now, if it's a positive leading coefficient and it's an even degree, both sides are going to be up. An example of this would be like 2x to the fourth power. Okay? And they are both positive. That means as x goes to negative infinity, f of x goes to positive infinity. And as x goes to infinity, f of x goes to infinity. Okay? Now, if it's even and it's negative, they're both negative. They both go down. And then both of these, as f of x goes to negative infinity, it would go to negative infinity. And as x goes to positive infinity, f of x would go to negative infinity. Okay? Now, for the odd degrees, you're going to start low, end high. And you always end the way that if it was positive, you end positive. If it's negative, you end negative. Okay, so if it's an odd power with a positive coefficient, as x goes to negative infinity, f of x will go to negative infinity. And as x goes to positive infinity, f of x will go to positive infinity. Okay, now odd power negative coefficient, that's where you start high, so you start positive and you end negative. And that would be positive infinity and negative infinity. Cool? Okay, let's look at this. So you do need a graphing calculator for this. So if you have one at home, pull it out right now so that you can go through this with me. If not, just use the table that I put up on here and then make sure that when you come to class tomorrow, you grab one of my calculators. Okay? So we're going to go to y equals and you're going to plug in 3x to the 6th. And you should get a graph that looks similar to that. Now, we need to just pull up the table. That's how we're going to graph these, is from the table. So if you push second graph, it will get the table, and you should get a table that looks like this or has the numbers like that. And I usually go from -3 to 3. That gives you a pretty good range. Now, obviously, I'm not going to graph the point -3, 2,187, because that's clear the freak off the graph. But I'm going to do -2. No, I'm not. -2, 192. That's clear up there also. So I'm going to do -1, 3. So that's going to be right there. 0, 0, 1, 3. The rest of those are way, way up there, and I'm not going to deal with that. Okay, and so there is my graph. Now, if you want to pause this and go through that right side, go for it. If not, I'm just going to go through it right now. So the domain, that is your x values. And that's going to be negative infinity to positive infinity. And I just want you to write this in interval form. Unless I tell you otherwise, write it in interval form. Okay? Range is your y values, and that's 0 to infinity. So 0, because that's the lowest point on the graph right there. And there's a bracket on 0 because it equals 0. Okay? X-intercept, it crosses at 0, 0. And make sure those are points. You have to write those as points. Okay, y-intercept is also 0, 0. Now, increasing and decreasing, this is always x values. Every single time, this should be x values. Remember, increasing is when you're walking uphill, decreasing when you're walking down. So that's going to be 0 to infinity. Decreasing is going to be from negative infinity to 0. And this is always parentheses. Every single time, always x values, always parentheses. Okay, symmetry, this is symmetric about the y-axis, which means it's even. There's no discontinuities, or I still don't know how to say that word. But yeah, there's none of them. And end behavior, so if I look at the left side, as x goes to negative infinity, that's going up towards positive infinity. Same thing with the right side, that's going towards positive infinity. Okay, skip those next two graphs. Let's go to this. So flip the page. Recall that f of x equals, if it equals x to the negative first power, that's really the same as 1 over x. And this is called the reciprocal functions. So power functions with negative exponents are undefined when x equals 0. Therefore, they contain discontinuities. That means they have asymptotes. Because you can't plug 0 in for x right there, or you're going to get 1 divided by 0, which you can't do that, because you can't divide something into 0 pieces. That just doesn't make sense. Okay? So let's look at this, and again, we're going to pull out our calculator, and we're going to graph it, okay? So 4x to the negative second power, and you should get a graph that looks like that. And then look at the table, so second graph, and go from negative 3 to 3. Notice at 0, there's an error, which means that there's an asymptote at 0. If we graph this, 0, or negative 3.44, negative 2, 1, 1, 4, 1, 4, 1, 1, 2, 1. That should be a 2. Sorry, this should be a 2. And then 3.44. There you go. Now my domain here, negative infinity to 0, 0 to infinity. Range is 0 to infinity. X-intercept, there isn't any. Y-intercept, there isn't any. Increasing from negative infinity to 0. Decreasing from 0 to infinity. This is symmetric about the y-axis, which means it's even. Discontinuities or whatever. It's infinite at x equals 0. Because at x equals 0, that's where the asymptote is. And then as x goes to negative infinity, that's going towards 0. And as x goes to positive infinity, that's going towards 0. Cool. We'll do the other examples in class, maybe, possibly, I don't know. Remember to take the quiz. You guys are awesome. Bye.